ఆవశ్యకం. KABTV అందిస్తున్న ఈ క్లాసులను చక్కగా ఫాలో అయి ఎగ్జామ్స్ మరింత చక్కగా రాయాలని మేము కోరుకుంటున్నాం. మరి ఈ ఎపిసోడ్లో మీ ముందుకు రాబోతున్న కెమిస్ట్రీ క్లాస్లోని టాపిక్ ఏంటో చూసేద్దామా? రసాయన శాస్త్రం. భవిష్యత్తులో ఈ రంగంలో రాణించాలంటే ఇంటర్లో నేర్చుకున్న అంశాలే ప్రాతిపదిక. అందుకే ఇంటర్లో కెమిస్ట్రీని నిర్లక్ష్యం చేయొద్దంటారు అనుభవజ్ఞులు. అందుకే ఈ అంశాన్ని సీరియస్గా పరిగణించిన KAB టెలివిజన్ కెమిస్ట్రీ బోధనలో 29 సంవత్సరాల అనుభవం ఉన్న R.SATYA గారితో ఈ క్లాస్ కండక్ట్ చేస్తున్నాం. కెమిస్ట్రీ సబ్జెక్టులోని కీలక అంశాలపై ఆయన టిప్స్ ఏంటో ఈ ఎపిసోడ్లో తెలుసుకుందాం. ఈరోజు ఎపిసోడ్లో సీనియర్ ఇంటర్ కెమిస్ట్రీ పేపర్కు సంబంధించిన గ్రూప్స్ టాపిక్స్ గురించి తెలుసుకుందాం. IPE పరీక్షలో గ్రూప్స్ టాపిక్స్ నుండి 10 నుండి 12 మార్కులకు ప్రశ్నలు వచ్చే అవకాశం ఉన్నందున ఈ అంశాన్ని నిర్లక్ష్యం చేయడం ఎంత మాత్రం మంచిది కాదంటున్నారు విద్యావేత్తలు. ఈనాటి ఎపిసోడ్లో ఎలిమెంట్స్ ఆఫ్ గ్రూప్స్కు సంబంధించి 5A, నైట్రోజన్ ఫ్యామిలీ, ఆక్సీ యాసిడ్స్ గురించి తెలుసుకుందాం.
Dear students, today I want to discuss elements of group 5A, which is also called the nitrogen family, and I plan to do this in the form of questions and answers. I would rather pick up some questions first, and then while giving the answer, I can actually give you the whole picture of the periodic table. So I just now start elements of group 5A. Elements of group 5A. They are also called nitrogen family. So, with any group of the periodic table, what we should know are the elements and their atomic numbers. So, first question, what are the elements of group 5A? We have nitrogen, phosphorus, arsenic, antimony and bismuth. These 5 are the elements of group 5A. You might be surprised why antimony is called Sb. It is actually stibium. It is a Latin name. So, the symbol happens to be Sb. And how to find out atomic numbers, not just with this group, with any group for that matter. Suppose the atomic number of nitrogen is 7. How can you go along the group? So this is the rule, in fact, you have to use. Between 2 and 12, you add 8. That is, the number right now you have is 7. When you add 8, you get the atomic number of the next element, that is phosphorus 15. 2, 12, between 12 and 39, add 18. Greater than 39, add 32. Look here. Between 2 and 12, both inclusive. Both of them are included. Even for 12, we have to add 8. So, since nitrogen is 7, the next element happens to be 7 plus 8, 15. And what will be the atomic number of arsenic? Between 12 and 39, you are asked to add 18 in fact. 18. So, 15 plus 18, 33. So, what do you add to 33? Once again, it falls in the same range, that is 12 to 39. So, add 18 again to get 51. And 51 falls in the last range, add 32 to get 83. It's not just with this group, any group, same rule holds good. So, today we will be discussing 5A, tomorrow or some other time we will be discussing 6A, 7A, but the rule holds the same. Less than 12, add 8. Both inclusive, look at the arrow heads. On both the sides you have arrow. Here including 39, greater than 12, less than 39, add 18. So first question, what are the elements and what are their atomic numbers? And this will be the question in all the groups. In all the groups of P block, so-called P block we have. That's the first question. Second question, elements of this group, they are called nicogens. What do you mean by nicogens? What do you mean by nicogens? Look at the spelling, it is PNI, nicogens. Their compounds cause suffocation. They are called nicogens because compounds of the elements of this group cause suffocation. For example, you have N2O, nitrous oxide. It is also called laughing gas. It is used as the modern day anesthetic. While surgeries, it is anesthetic. And most of the compounds of arsenic are poisonous. Phosphine is a poisonous gas. So, most of the compounds of the elements of this group cause suffocation. So, why are they called nicogens? Their compounds cause suffocation. Suffocation. That is the second question. Next. What are the physical states of these elements? Nitrogen is a gas. Phosphorus, arsenic, antimony, bismuth, they are all solids. Phosphorus is a solid and so are the rest. And of course we have learnt about group 5A. How can you tell me about the physical state of 115 elements? We have 100 odd elements. How can you say? There is a very easy way out. First list out all the gases. How many are gases among all the elements? Gases among all the elements. We have a handful of gases only, not many are gases. Helium, neon, argon, krypton, xenon, radon. These are from the 0 group or the 18th group of the periodic table. They are gases. Fluorine and chlorine from the 7th group, 7A. They are again gases. Oxygen is a gas from the 6th group. As we have seen, nitrogen is a gas from the 5th group. And hydrogen. Only these are gases. Only these are gases. Helium, neon, argon, krypton, xenon, radon from the 0 group. Fluorine, chlorine from the 7th group. 6th group, 5th group. Hydrogen, of course, 1st group. Fewer still are liquids. Just 2 of them are liquids. Bromine and mercury are liquids. Liquids. Bromine and mercury. There is some doubt about gallium, cesium and francium. Why do we have any doubt? Because their melting points border on the room temperature 28, 29. Strictly speaking, we can't consider them as liquids. So let us not worry about gallium, cesium and francium. These three, let us put a question mark. We need not worry about their physical states. So you have a handful of gases, just a couple of liquids. All others are solids. So you just we have applied the principle for group 5A, not exactly a principle. How about any other group? Suppose you have 7th group. Fluorine and chlorine are gases. Bromine is a liquid. All others, whatever they are solids. Oxygen from the 6th group is a gas and there is no liquid in that, so all other elements are solids. So just by learning few gases and a couple of liquids, now you can know the physical state of all the 115 elements. So it's not just group 5A, you can learn the physical state of all elements of all the groups, 6A, 7A, even 0 group. Now, how does PCl3 react with water? You can also call this as hydrolysis of PCl3. Look here. Here I am just talking about PCl3, but the procedure we use is useful in discussing all reactions with water, or reactions of all the compounds with water. Look here. PCl3. How does it react with water? to know the answer, you break the bond. You have in fact 3 bonds here, break 3 bonds, and you write 3H here.